So yesterday we have done till your image enhancement. Today we'll be taking a new feature on image enhancement, and we'll be discussing spatial filtering. Just like if you go to any hill station or you go to any glaciers, or when there is a fog in the atmosphere, then you will see that many vehicles have got a defogger, or there is a filters that are attached to the glacial terrains or the mountainous terrain. Why does we apply a filter? The filter reduces the effects of scattering in the atmosphere. So whatever is scattering that is happening, and there will be a reflection. So when you are applying a filter, those kinds of hindrance noise in the image will be removed. So in the same way, when there is a satellite and it is stationed at a very far location from us, many times there are various kinds of atmospheric errors, that can be fog, that can be cloud, that can be water vapors, water particles. So that create noise, and if you are continuing it with the same image, if you are not rectifying it, what you are doing, you are trying to exaggerate the error that was produced in the input. If there is an error that you are not rectified in the input and you are continuing it, first the visibility of the object will be poor. So if the visibility of the object is poor, that states that the quality of the image is poor. And at last, if you are finally classifying either through visual classification or through digital classification, because the features are not clearly visible in the satellite image, you cannot have a highly accurate classified image. So the accuracy level can vary from image to image, and it will be on the lower side. And if it is on the lower side, the accuracy is poor, nobody is going to accept that database or the results what you have generated. So that will be a kind of superficial classification that you have done with no accuracy. So in order to get it done, you have to apply various kinds of filters in the satellite image, and for that we'll be reading what are the different kinds of filters that we'll be using in our satellite images. So I'll start up my presentation where we stopped yesterday. Can you see the slide?
Yes, sir.
So yesterday we have seen what are the features where we'll be seeing codes, when we'll see rough, when we'll see say high, when we'll say low. So when a high frequency image is there, means the texture is rough, and where there is a low frequency image, the texture is smooth, because the spatial variation is low along the pixels, and in this high frequency the spatial frequency is very high. So the spatial frequency we have already discussed yesterday, some of the part of it, that image is composed of high frequency details and low frequency. Any satellite image will have a high frequency and a low frequency details. So what does that high frequency and low frequency details tells about? It tells about that low frequency details, few changes in the brightness value over a given area, means there will be a few changes in the image, and in the high frequency image there will be a lot of changes in the smaller given point of time. So you can see this image, there is a three figures that we have given it. The number one is zero spatial frequency, second one is low spatial frequency, and the third one is high spatial frequency. So what does it denotes? It denotes that the variation is very low in zero, and it is continuously moving in low frequency, and it is abrupt in a high frequency where it will be looking like a chessboard pattern. So the image will be rough in high frequency, it will be low in the case of moderate, it will be texture, and in case of zero spatial frequency it will be having a smooth pixel. So now today we'll, as we have already completed our enhancement, what are the different kinds of enhancement that you will be doing, the linear enhancement and the non-linear enhancement. Today we'll be continuing with the spatial filtering. So as I have already stated why we are going to use filters, the spatial filtering is the process of dividing the image into consecutive spatial frequency where where selective altering certain spatial to enhance some image features. Means when we are using these filters, we want to specify or we want to highlight some specific features. Like if you want to go for landslide hazard zonation, in India, you will find that maximum landslide occurs during the weaker planes of the rocks that are along the fractures, along the joints, along the uh, lineaments, so that are smaller object in an image or a smaller feature in an image. So if that is a smaller feature in an image, you will, because the majority part is covered with the other land use land cover object, that will be suppressed in the your image. So what you want to do, if you want to do a landslide generation, you want to highlight those structural features, because along those structural features, maximum landslides do occur. So in order to get that features enhanced, we'll be using various kinds of spatial filters, so that the minor object or the minor feature which are suppressed in the satellite image can be probably or predominantly highlighted, so that you can have a real understanding of the tectonic disturbance and the tectonic feature in an image, and you can highlight the weaker zones where there is a possible of risk to be happen, and then you can classify that into different range according to its weight, into high category, moderate category, and low category. So what does the filtering do? It is a process of suppressing, means you will be suppressing some feature and you will be highlighting some feature. You will be given with a task that you have to highlight some features related to whether you go for water conservation, watershed management. There also you have to highlight the structural features, because they are the planes along which you can get the maximum potential of water. So what does filters do? It suppresses some features of certain frequency and emphasizes some other features. So this technique increases the analyst ability to discriminate details. So what does this filter do? Because you are highlighting some features and you are suppressing some features, if you want to highlight one specific feature, that will be highlighted in your image and the other will be suppressed. So whatever understanding or whatever mapping or whatever modeling you are trying to do, this kind of filters will add on to your existing model and you can have a better understanding of the terrain. So we can also say that this is a local operation. Why this is a local operation? This is not a regional operation, because it is, when I said that I'll be applying that to specific features like joints, fractures, cracks, lineament in case of water conservation or in case of disasters, the ranking will change according to the objective. So we can say that the operation that we are doing, the fractures, the cracks, they are the local operation. Means pixel value is modified based on the value surrounding it. Means it will be not changing the entire values of the satellite image, but it will be changing the value of that feature on the basis of the surrounding values of the pixels. Means you are highlighting some feature, you are suppressing some feature. Like in a class also, if there is two or three persons who are very prominent in personality, who are good in communication, who have got a good personality, so whenever there is some external agency or body, or when it comes to placement, those features are pushed forward so that they give a real and a good impression of the entire class. So in the same way, if you want to go for some kind of mapping, maybe many times you need to highlight some specific features and you have to suppress some specific features. So under that, we'll be using this spatial filters. So what does it does? It removes the noise in the image. Like I've already stated that the noises can be fog, it can be water vapor, it can be other noise, aerosols, dust particles. So when you're providing these filters, your image will be more smooth in nature, Why it will be smooth in nature? As we have already stated that the high frequency image will be removed and you will have get a more smooth image. So you can see where are the low and high frequency image, that in between this forest you have got some agricultural land inside the notified forest with some riverine beds, and then you have got the rivers, the settlements, the agricultural land, and roads, railways. So if I want to highlight, if I am working on a smart city, my prime focus will be mapping of existing network and then going for the new areas or the new locations where we can go for a new transport connection. And for that, because these features are very small and because it is a majority of the part is covered by the other regional features like you can see rivers, you can see forest, you can see agricultural land, that is suppressing the railways, that is suppressing the roads. So if I want to highlight only those linear features, then I have to run some specific features and specific filters. So what are those filters? Filters are algorithms, nothing else. So what we do, we apply various kinds of convolution filters with a mask size of various shapes. Generally it is of, it will be always on a odd basis. Why it will be odd basis, we'll be coming and we'll be discussing now why we are creating these filters and how it is run. It will be running in the entire image, uh, one after other, one after other. So what is that convolution filtering technique? So that is a process. The most popular process when you are doing any kind of filtering is convolution filtering technique. So what does convolution filtering technique does? It is a process of evaluating the weighted neighbor pixels value located in a particular spatial pattern around the iz location of an input value. As we have already stated that the pixel value will be decided on the basis of your surrounding value. So what you're doing when you're creating a matrix, so matrix, what you will get, you will get a centralized value at the center of this. If I have taken this 3 is to 3 kernel, so what it will do on the basic of all these nearing pixels, I'll get a value of this middle pixel, and this formula and this filters and this methodology will be applied for the entire image, and it will be moving slowly so that the features that are suppressed can be highlighted in your satellite image. So what is does, it masks a window is placed over a part of image. So you have got an image and you will apply a filter. So apply filter will be just like a window that will be running in the entire image. So what we have created, we have created a 3 into 3 pixel size, and then on the basis of the surrounding values of the neighboring pixel, the centroid value of the pixels is evaluated, and then this filter is moved on the entire satellite images. So you will get a more pronounced, and the features which were suppressed can be easily highlighted. So this is a mask window that moves over the part of an image. Convolution formula is applied over the part of the image. So whatever formula you will be applying for different filters will be applied in those filtering windows, and it will be moving in the entire satellite image. So what is that prominent formula that we are using? That is sum of weighted product is obtained, that is coefficient of mass into raw dn value divided by sum of coefficients. So again, you can see that when you're creating a filtering, there is a mathematical equation. That's why we have taught you fundamentals of mathematics in the first semester, because many portion didn't have or may not have good understanding of mathematics. So it was introduced in your syllabi so that when you will be performing the digital image processing, you can understand the basics and the fundamental and what kind of operation that we are doing and what kind of results is expected when you are applying a particular formula or a particular filter. Generally, whenever you are applying these filters, You have got a user interface where you will be selecting an image and you will be getting a output image by selecting a kernel in between. But the background, what is the basis on the which this entire operation is done, we are going or we are studying right now, so that you can know what are the logic that has been applied for the creation of specific filters. So the central value is replaced by the output value. As I have already stated that we'll be taking a odd pixels of 3 by 3, 5 by 5, 7 by 7, 9 by 9. But as your filter size will increase, the amount of information will differ, means it will be more generalized inside. So try to keep your filter size as smaller as you can, because it will be near about giving the same value what it was expected in the original image, and the same value will be in the output image. But if you're taking more bigger size or the more bigger filter size, what it will do, it will try to accommodate more number of pixels, and it will try to average the values of those pixels. So what will happen, instead of getting a high frequency image, you will be getting a smooth and a coarser or a low frequency image. So always try to keep your filter size as small as can. The smallest size filter is 3 by 3 or 3 into 3 filter size that we use, and that is run in the entire image. So window is shifted by 1 pixel and the procedure is repeated for the entire image. So what I have already stated, that this kernel, you can also say this filter as a kernel, is applied in the entire image, and those filter will be moving so that you want to highlight whatever feature can be highlighted using those filters. So what is this convolution process does? It uses 3 by 3 kernel. So what we are making the matrix, what I have stated is the matrix that we are creating, and the kernel size is 3 by 3, and the results in the output will be in 2 lines and 2 columns smaller, means it will be giving only the centroid value, and that value has to be replaced in the output image and in the input image. So boundary pixels are either copied from original image or duplicated from the sign and then computed. So how does it happens? So you see, this is a pixels. Generally, whenever you see a satellite image on the left hand side, you will be seeing such kind of colors in your satellite image. When you convert or when you see to the metadata, how this color has been generated, so those colors are generated on the basis of its distal numbers. These distal numbers are nothing but the radiometric resolution, what we stated, that is the color between 0 and 255. What is the range? So at it is towards the 255 value, you will be getting a brighter image, and as it is towards the 0 value, it will be towards the darker image. So you can see that this is the image, this is the metadata on the basis of which this satellite image was converted. So you can see that there is a pixel which denotes a value 164, 188, 164, 161. So these values are nothing but different earth object that our satellite records, and then we process and then we convert those digital numbers in the form of colors for the real representation of the odd feature for its mapping. But when you are applying a filter, it changes the distal number. So how those distal numbers are changed when you are applying a filter, we are reading that. So you can see that in the current example, we have taken 3 by 3 kernel. So when we have taken 3 by 3 kernel, so what it will do, it will select 9 pixels. 9 pixels means 164, 188, 164, 178. So this is row number 1, row number 2, row number 3. In the same way, you will be getting 3 rows and 3 columns. So that makes 3 by 3 kernel, and you will be applying the central value will be replaced on the formula what we have already stated, that each and every operation has to be masked. So what is the operation? So we'll be applying the mathematical formula in this filter in order to replace the centroid value of the pixels or the kernel, so that we can get a more highlighted, a more clearer image, so that our feature which was suppressed can be prominently highlighted and will get a more prominent image. So this is the way the filter is used, the kernel is used, and the centroid values is replaced in the each value of the pixel, and this kernel is moved in the entire image. So you'll get a new value, that is 186 instead of 201. So after using this formula and after using this matrix what we have created, you can see that how we have multiplied this and we have created a matrix, and finally the output of that matrix is 186. So instead of this value of 201, after applying this matrix, the new value on the output image will be 186. So after applying this filter, you will see that before filter the image were more kind of smoother in nature, but after applying the filter what we have done the operation in the earlier operation, you will be getting a more clearer, a more high spatial frequency image. So generally when you will be applying using the remote sensing softwares, you will be getting such kind of products. But what is the background on the basis of which you are getting this product or the output, that we are discussing how it is generated. Clear hai?
Yes, sir.
So you have got various kinds of filters that are used for enhancing or suppressing any particular feature. The more prominent and the more popular filters that are used for highlighting or suppressing or removing the noise in the image are low pass filters and high pass filters. So now we will be reading what do you mean by low pass filter and what do you mean by high pass filter. So low pass filters block high frequency details. So what it will do, because we are saying low pass means lower frequency must be highlighted and higher frequency must be blocked. So what it will do, it will block the high frequency details, means whatever abrupt changes you will be finding it will be suppressed. So when you will get an output image, it will be more smoother in the image. For example, if there is a forest and in between if you have got 5 to 6 pixels of agricultural land in between it, so when you are applying the low pass filter, it will remove that agricultural land from it. So what it will have, you will get a more kind of a smooth effect on an image. It is used, low pass is generally used for removal of noise. So whatever noise, haze, whatever you have got in an image, that can be removed. Second removal is salt and pepper noise, that we have already studied in your radiometric correction, that will be removed. And blurring of image, especially at the edges. So many times you will be seeing that they are blurry or a hazy image along the borders of a satellite image. So when you are applying a low pass filter, such kind of features will be highlighted and you will get a more clearer image. When to use just the opposite of a low pass filter, the high pass filter will act on. So what does high pass filter will do? The high pass filter preserves the high frequencies and removes the slower varying component. So what it will do, the higher frequency image like the you say the roads, the railways, the linear features will be more prominently highlighted and the other features will be separated. It enfaces the finer details. So whenever you're trying to see any boundary of any agricultural land or any plantation or any structures that is linear in nature, and you want to emphasize the smaller details that are in the satellite image, but that has been suppressed because of the larger features, when you are will be applying the high pass features, such features which are smaller in details in your satellite image will be prominently highlighted. So it is used for edge detection and enhancement. So low pass filter generally is used for the edges, If you want to see the boundary of a satellite settlement or a agricultural land or a forest or a settlement area, so you will be applying the high pass filter, so that in case the edges are not clear in your satellite images and you are finding a difficulty of disguising it where to put the boundary and demarcate your area of interest, you will be performing the edge detection using this high pass filter. So edges are location where transition from one category to other category occurs. Because the edges are very important, because if you want to mark a boundary and if the edges are not clear, for example, there is a two agricultural land adjacent to each other, one pertain to Ramesh and the other pertain to Gopal. So if you are not making the boundary clear, maybe you will convert the Ramesh agricultural land and the boundary to the Gopal. You will find that every now and then there is a find in the villagers that many people do disturb the bunds so that they can convert their agricultural land and they can increase their agricultural land, and there is a fight along the boundary, and the boundary of dispute is we have got a boundary dispute with Pakistan, we have got a boundary dispute with China. So many times you will be, when we'll be settling up with those Pakistanis and the Chinese, will be using this filter to get the exact location of the boundary that we have stated that this is our Indian territory, and one day you will get our land what it pertained to us. So at that point of time, such kind of high pass filters or the age detection filters will be a great use to the military in order to understand the boundary along the borders. So what are the different kinds of high pass filters that we are trying to do? So high pass filter, just like your contrast enhancement, or you can say age enhancement or image enhancement, you say, you we have divided that into linear and non-linear transformation. So in the same way, in the high pass filtering also, we have divided the entire operation into linear and non-linear operation. So what does linear operation do? The linear operation, the output brightness value is a function of linear combination of BV, that is located in a particular spatial pattern around I and J and location in the input image. It is the same what we have stated. Null here, it's used non-linear combination. So in this we'll be using, in linear we'll be using minimum, maximum, stretch, cut, those all features what we have stated. In null here, log, then histogram, equalization, and such kind of filters will be taken into consideration for doing such kind of operation. Then the most popular and the most common is age detection. So when you will be performing the age detection, the background will be lost. Background means many of the features will be removed and only the edges of the boundary what you are looking for will be highlighted in your satellite image, and all the features will be removed. So this all operation whatever we have studied will be doing in our labs, so that you will have a better understanding and a clear understanding of the entire operation that we have done or we have studied theoretically. Now we'll be doing in our coming class practically. So what does age enhancement does? It delineates the edges and makes the shapes and details are more prominent. So when you're performing a high pass filter, what will happen? The output image what you will be getting, in that the edges and the shapes of the boundary along the borders will be more prominently seen, but the demerit, you can say, the background is removed, means all the features will be suppressed, only the edges will be highlighted. So this is the most popular filter that we used for age detection, that is the Laplace edge detection and Laplace age enhancement filter. It is the same filters that we have used or we have already studied in yesterday's class. These are the some additional directional filters. So some of the features are directional, some of the features are non-directional. So what, when somebody asks you what do you mean by directional feature or what do you mean by null directional filters? So directional or the age detection filters means the high pass filters are designed to highlight the linear features such as rolled or filled boundaries. I've already stated that whenever you want to highlight the roads or the bonds of agricultural land, you will be using these directional filters because they are linear filters and they work good for linear shape and size of the objects that are in the earth. Next is these filters can also be designed to enhance which are oriented in a specific direction. So if you have got a specific direction of drainage or slope or some other features which have got a specific direction property that denotes to a specific direction, this filter will give you a better result for such kind of filters, especially for geological understanding where the detection of linear geological structures are important. As I've already stated that if you want to go for geological mapping investigation of dam construction or water harvesting sites or landslide or avalanche mapping, then you have to see for the weaker zones, and for delineation of those weaker zones you have to use this edge detection filters in order to highlight those fractures, cracks, joints, lineaments, so that you can have a real understanding of the terrain and you can have a near real time detection of the various earth features. So you see that how these features walks on different direction when you apply. So the mass name suggests that the slow direction of maximum response. Example is east gradient marks provides a maximum output for the horizontal value when it changes from west to east. So you have got 9 direction which we have already studied in your earlier semester, that how you will be classifying the entire region into slope into direction. So you can see that how these filters are properly moving. The second important feature that we have to be looking at is image transformation. So whenever we are doing any kind of digital image processing, what we are doing, we are transforming the image. Transformation means we are changing the values of the original image on the basis of some specified filters or some specified enhancement technique in order to have a better understanding of the subject or the feature. And such kind of operation is done means transformation means if you have been taken admission into the MSc or MTech program in geoinformatics, and post completion, if nothing has changed in your life, either your personality, either your theoretical knowledge or your practical knowledge, we as an institute or I as a teacher or we as a center has failed because the purpose for which you joined this university was transformation in your personality. So you will see that our university act and work on the total transformation of the student, whether it is pertaining to the personality development or whether it is into the practical aspect of the subject. So image transformation typically involves the multiplication or manipulation of multiple bands of the data. So you have seen that you have got various bands. Each band comprises various distal numbers, and we have to use this distal number. You have to manipulate this distal number so that you can get a meaningful operation. You can get a meaningful answer to the problem, to the objective you are searching for. And for that, you'll be using the various digital image processing techniques, whether from a single multispectral or from two or from more images of the same area are acquired at different time. So why this kind of digital image processing we have to read, and why we have to learn this all techniques? Because you see that we have got a series of data that is available with us with a series of sensors, like from 1972 onwards you have got Landsat with MSS, then you have got TM, then you have got ETM plus, now you have got OLI. In the same way, for lease series, you have got lease 1, lease 2, lease 3, lease 4, then Cartosat 1, 2, 2B, then you've got Iconos, Quickbird, Modis, all are on different dates with different bands with different band combination. So because we are acquiring the data on different dates, we are acquiring the data from different channels, from different sensors. So every time you have to check the visibility of the satellite image, you have to check the accuracy of the satellite image because until unless you are not able to see this entire operations, and if there is an error you have to rectify. That's why the image transformation that we are trying to do with the help of different digital image processing techniques must be thoroughly understand, must be practically done, so that when you are into the real time operation, when you are doing, you can get a better understanding of the subject. So either way, image transformation generates a new image. So always when we are doing any kinds of filtering or any kinds of enhancement or any kinds of classification, obviously we'll get a new image from two or more sources which highlight particular features or property of an image which was better than the original input image. So what is the purpose? The purpose is there is a problem in your original image, that is the image that you want to study, but there is a problem. There are various kinds of geometric, radiometric enhancement is required, filtering is required. So this entire operation has to be performed to get the image transformed so that you can get a real representation of the image. So many times, apart from your filtering techniques like low pass, high pass, directional filters, non-directional filters, you have to use various kinds of band ratioing operation. Band ratioing operation is means you want to use the better properties of any particular band, and then you want to get, like if I want to get our vegetation highlighted from the given satellite image. So we have got a particular index or a formula that will be applied so that our vegetation can be prominently highlighted. On the vice versa, on the other hand, if you want to highlight the water features, like if I am from forestry and if somebody is from water, why should I bother about water? And a person from forestry, if his job right now is to identify the various species of forest in that area, then why he should be bothering about the water? And for that we have got specific filters that has been designed so that only those features of interest where you are looking for can be highlighted or can be mapped. Like for vegetation, we use the band ratioing technique, that is NDVI, that is normalized different vegetation index, that will be reading in detail tomorrow. Then if you want to highlight any particular water feature, then we'll be highlighting then normalized difference water index. If you want to highlight snow area, then you will be using normalized different snow index. If you want to highlight, I'm an urban planner, I want to see only the build-up area and the build-up features I am concentrated in, and I have to list water about the vegetation, I have to list water about the water, I have to list water about the snow. So I've got a specific indexes that is known as NDVI, that is normalized difference build-up index. Then if I want to see the area which has got the turbidity in any particular water, there are four or five water sites available in an area, and I want to see the turbidity which water is pure, which water is impure. So we have got the various indices that is known as normalized difference turbidity index. So you can see that the remote sensing and GIS has given you ample number of guns, weapons to fight among the enemy. So whenever you are going for a war, you'll see in our military that we have got three kinds of army. You have got three kinds of protection. One is through naval, that is Indian Navy does our protection of our oceans and the border is kept safe. And for the air, you have got Air Force which see and protects of air. And for protection of our land, you have got the army or the territorial. In the same way, according to your objective, according to the plan, the digital image processing have given you the entire weapons. The weapons are the various radiometric correction weapons, geometric correction weapons, age enhancement weapons, filtering weapons, band ratioing of weapons, and finally you have to apply this weapon to fight against the army. The army and the enemy here is a problem. The problem is that our population is increasing, and the demand and our land is too small, the water is precious, the number of days of water is reducing. So what you have to do, you have to utilize this water, you have to utilize this water in such a way that the productivity is should be increased, so that we have surplus amount of food grains, so that we don't have any food problem, we don't have any water problem, we don't have any vegetation or fresh air to breathe in problem. And for that you need to know about your earth, and for understanding of the earth you need to know about land, you need to know about forest, you need to know about water. And most of the terrain are inaccessible, unapproachable, time consuming, and multiple area or expertise is required. And for that, the remote sensing and GIS geoinformatics provide you the best solution, where all this digital image processing technique that you're studying can be applied, and finally you can conclude at end what can be the future scenario of any particular city. What if the current trend continues, what will be the future? If the current forest type is today, what was tomorrow, we can predict about future. In the same way we can say about water, what is the demand, how much we are protecting, how much it is going as a runoff. So this all can be done only using the digital image processing, because correction of the data is very important. Understanding of the data is very important, because directly you cannot use a software and you cannot run a operation until unless you are not knowing the background, the logic, the mathematical transformation, the mathematical formula that we are applying. And finally we want our image to be transformed in a such a way that whatever is our objective, whatever is our goal, whatever is our motto, to get that problem solved, this entire operation will make you healthy, will make you confident that the results that you are generating is nearly about 100% accurate, so that the government of India or the decision makers or the state government can use these data sets for future planning for the development of the society. Because we have to see what does the UN has given us. UN has given us 17 sustainable goals, and in order to make that goal achievable, that is also known as millennium goals, we have to use this digital image processing techniques to justify, to fulfill all our dreams that the various persons or the scientists or the researchers are dreaming of. And with this, I'll be ending up today's lecture. We can start a group discussion. Thereafter, I'll end my class. Hello.
Yes, sir.
So anybody can just in 2 minutes refine what we have studied today. Anyone? कोई भी बता दो.
So today we are study filtering. Filtering size is smaller, 3 by 3 are more comfortable to identify satellite image.
Why anybody? Why we apply a filter? What is the purpose? Why we want to apply a filter? What is the logic?
Sir, correct to satellite image. Satellite image have more errors at radiometry errors and geometric errors.
Yes.
Do filters to correct it.
Okay.
That's why using
Okay.
filter.
Anybody else wants to add to it? Rishabh, you want to add to something?
Yes, sir. Sir, we used image enhancement technique. The image was very blurry. The image was very blurred that we can apply this technique. The image verification clear. We see clear image.
And the purpose is, you see, many times there are smaller details in the image that you want to highlight. So in order to highlight, you have got a high pass filter. If you apply a half pass filter, you'll get a better understanding of the lower features or the final features. So according to your objective, you will be redefining it. So please read the textbook Kiefer, Bhatta and Campbell and Woods for a better understanding of the theoretical topic that I have taught you right now. A more in detail knowledge you will be getting it. So please consult that book. And for today, I think that it's okay for today's class. And with this, I'll be ending and stopping my class.